Hi, and welcome to 6.1 example 1b. So again, we are graphing the solution set for this linear inequality. In this case, we have 2x plus y is less than or equal to, so that tells us that points on our line can be part of our solution set because it's less than or equal to. The equal to part tells us that. And they're whole numbers. So whole numbers don't include fractions and decimals. So that will change what our actual graph looks like. Okay, so first thing again is we want to graph the actual line 2x plus y equals 4. That's the first step, is to graph that line. So in this case, y equals mx plus b would be in order again. So it would be y equals negative 2x plus 4. And so to do that, we've got a y-intercept of 4. We've got a slope of negative 2. Remember, negative 2 could also be written as negative 2 over 1. Right, so that means we're going to have a rise of negative 2 and a run of 1. And remember, a rise of negative 2 means it will go down 2. Okay, before we can graph it, we need to go and label our axes. So we've got our x-axis, our y-axis, and we want to put our scale onto our graph. Again, our scale can just be 1 per box because we're looking at numbers like 4 for our y-intercept, and our slope is negative 2, so we're not going to deal with any huge or very small numbers. Okay, so we can label on here a few of these. Okay, one thing that should be noted in this question is that this is the whole number set. So that means anything in this quadrant, this quadrant, this quadrant, we're not concerned about, because our only solutions have to be within the area of positive integers, is essentially what a whole number is. So we don't have to worry about these quadrants. In some questions though, note, we will have information that has us start graphing like down here, but then we don't actually care about the information until we get up in here. Okay, so what we want to do here is put our y-intercept onto the graph. So our y-intercept is positive 4, so we put a point there, and our slope is negative 2 or negative 2 over 1. So then we go down 2 over 1. And we could do it again. We go down 2 over 1. We get another point. Okay, that's probably enough to draw a line. So we take our ruler, and we could draw a line through there. But actually, when we think about this question, if we drew a line here, right, are there any other whole number points on that line? Well, no, they're not. There isn't. So if you draw that line, it's not a huge deal, but you need to recognize the fact that the only points on that line that are solutions are actually these 3 that we already have here. So now we're looking for, okay, which side of this, I guess I could put that line back there just to help us recognize what we're actually looking at. Which side of this line represents the solution set? So again, remember, we could do that by using a test point. So again, we could take a test point 0, 0, and we want to see, is 0, 0 in the original solution set, right? So the original equation is 2x plus y less than or equal to 4. So we want to know, is the less than or equal to part above or below that line? So we sub into this equation 2 times x, which is 0, plus y, which is 0. And we want to know, is that less than or equal to 4? So we get 0 plus 0, so 0 is less than or equal to 4. Is that true? Yes, it is. So that means the area below this line is our solution set. In this case, we don't shade everything in because our answers are just whole numbers. So instead of shading everything in, we instead will just color in the points. So we look for whole number points. So for example, this one right here is a point. 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 This one and this one. And those are, in fact, all of the solutions in this solution set. So instead of shading for whole numbers, we use points. That gets a little bit trickier when we're dealing with graphs with a different scale, but for graphs like this, we can kind of easily graph just each point. So again, our solution set are these 1, 2, 3, 4, 5, 6, 7, 8, 9 points that are below that line. And again, that line really doesn't need to be there, shouldn't be there.